we are going to discuss about probability distributions. Here in this probability distribution, here in the main objective of the probability distribution, how your distribution is spreading a data. Distribution is nothing but spreading that data with respect to the probability values. Probability distribution is but how your probability values are spreading within a range. Probability distribution, it means how your probability values are spreading in the surface. Here the probability values are two types. Like probability is a range. Ideally, what is the probability value range? Ideally, the probability value range is in between. Ideally, the probability value range is 0 to. So the distribution we may look at what particular point, or the distribution we may look at certain range. Let's say from one point to other point. So that means probability distribution has been classified into two different types. Probability distribution has been classified into two different types. Okay, probability distribution has been classified into two types. First one will be discrete distribution. Second one is continuous distribution. Discrete distribution is nothing but it will explain the probability value at particular point, at a particular point. It will explain the probability. Continuous distribution means it will explain the probability particular range, explain the probability values within some range. It will explain the probability value at a particular point. Continuous distribution means it will explain the probability value within some range. Okay. Within some range. Again, discrete distribution has been classified into three types, as well as continuous distribution has been classified into four different types. Discrete distribution has been classified into three types. Discrete distribution has been classified into Three types. Those are, first point will be binomial distribution, second point will be Poisson distribution, Poisson distribution. Third one is exponential distribution. Discrete distribution has been classified into three different types: binomial distribution, Poisson distribution, exponential distribution. We will talk about one by one in detail. First, what will the binomial distribution, what is the Poisson distribution, how binomial distribution is different from Poisson distribution, how Poisson distribution is different from exponential distribution. Now, let's see the first, before we are discussing about the in detail about the binomial distribution, Poisson distribution as well as exponential distribution. Let's have a discussion about the continuous distribution. Continuous distribution have been classified into four types. Continuous distribution has been classified into four different types. First one will be normal distribution. Second one is the T distribution. Third one is F distribution. Fourth one will be chi-square distribution. Continuous distribution has been classified into four different types: normal distribution, T distribution, F distribution, as well as chi-square distribution. Continuous distribution, normal distribution, T distribution, F, and chi-square distribution. Okay, let's have a discussion about the discrete distribution. Under the discrete distribution, first one is binomial distribution. Starting point is a binomial distribution. Binomial distribution means, bi means two, nominal data. What do you mean by nominal data? Nominal data is nothing but classifying the categorical levels of a data. Bi means how many levels of a data we have? Two levels of a data we have. Binomial means two levels of a categorical data. So what do you mean? What is the, how two levels of a data categorical means? Yes or no, 1 or 0, anything it will be. 1 or 0 also category kind of thing only. True or false basically. In this case, how my distribution will works here? In this case, we have the four different properties are there. First one is will be number of trials are fixed. Number of trials are fixed. What do you mean by number of trials? Number of trials are fixed, which are denoted with small n. Number of trials are fixed, which are denoted with a small n. Here in this case, what do you mean by number of trials? Number of trials means how many times you are running you are doing the events. Those are called as the number of trials. Here, so here binomial means two levels of a categorical data or two levels of output, either 0 1, yes or no, true or false. When you are going to get the yes or no, when you have done the some event, then only you are getting the yes or no. This is a binomial distribution, that is a binomial probability. What do you mean by the probability? Chance of getting of chance of getting or occurring of an event, that is called as the probability. Probability is nothing but chance of getting or occurring of an event. What do you mean by event? Any resultant outcome or a procedure, those are called as the outcome. So here in the binomial distribution, we are going to get the two outcomes. When we are going to get the outcome, when you run the events, then only you will get the outcome. So here number of trials are fixed. That means how many number of events should I have to do? That should be fixed initially before we are running the events itself. That is the meaning of number of trials are fixed. Let me repeat again. Number of trials are fixed. What do you mean by it? The meaning is that number of events are fixed. What do you mean by number of events are fixed? Before we are running the events or before we are performing the events, we have to assume that I am going to run these number of events. That is the reason we set the fixed. Why we set the number of trials or events here in this case? By using the binomial probability distribution, we are going to get the how many levels of outcome? Two levels of the outcome. What are the two levels? Either yes or no, true or false, 1 or 0, right? Anything it can be. So how do I get those outputs? We are getting by using the in the probability by using the events only. So here that is the reason number of trials we called as the events. That should be fixed. Before we are performing the event, we need to be make sure that before we are performing the events, we need to make sure that number of trials we have to assume. Is it clear? Second point. Number of trials are independent. Number of trials are independent. So for example, I toss a coin. Okay, a coin. I mean, suppose if I toss a coin, what are the possible outcomes we are going to get? We are going to get the two possible outcomes. What are those? Head and tail. Head and tail. So assume that in the first trial I got head. In the second trial, the scenarios will be: is there any guarantee am I going to get the head? No. Is there any guarantee am I going to get the trial? So irrespective of the whatever the outcome which we received in the first trial is independent of the next trial. So we can say that first trial is an independent with the second trial. Let's right. That is the meaning of number of trials are independent each other. Next, yes, die also the same, right? Let's say in that if I throw a die, first I got to assume that 3 number. Is there any guarantee second also I am going to get the 3? No. There could be a possibility I am going to get the 3. First I got the 3. Definitely I should have to get the 3. No. No such kind of things are there. So that is the reason each and every try is independent with the other tries. Right? Here third point will be two possible outcomes, right? In the binomial distribution we have a two possible outcome. Those are true, false, yes or no, 1 or 0, right? Here so two outcomes will be success or failure. Success or failure. We have the two possible outcomes. Those are success or failure. Okay. Is everyone is clear? Here, probability of success, fourth point. Probability of success is denoted with P. Probability of failure is denoted with Q. Probability of failure is denoted with Q. Huh? PP. P. Probability of success. Anything you can say A, B, C also. That depends on you. Probability of success is denoted with P. Ideally generated with the P, but people if they one thing they can denote with the A, B, C. Anything it will be fine. No issue at all. Okay. The mathematical formula for the mathematical formula is n factorial by n minus r factorial into r factorial p to the power of r into q to the power of n minus r. N factorial, n means total number of trials, r means probability of, no, r means how many events you want to perform, the race basically. P to the power of r, p is nothing but probability of failure, q is nothing but probability of, sorry, p is the probability of success, q is nothing but probability of failure. Here let me write down one by. Okay, let me write down again the formula here. Here n factorial by n minus r factorial into r factorial p to the power of r into q to the power of n minus r. N is nothing but denotions. N is nothing but number of trials. That means nothing but total number of trials. R is the how many trials you want to perform. R is nothing but how many trials you want to perform. P is nothing but probability of Q is nothing but probability of Q is nothing but probability of failure. P is nothing but probability of success. N is nothing but number of trials. R is nothing but how many trials you want to perform. P is nothing but probability of success. Q is nothing but probability of failure. Right? Now, in this case, what we are going to do? This is the mathematical formula. In the statistical, how do we perform this? If you want to find the mean, statistical mean is nothing but mu. The formula is n into p. If you want to find the standard deviation, that is n into p into q. N is nothing but number of trials, p is nothing but probability of success, q is nothing but probability of failure. Mu is nothing but mean, sigma is nothing but, this is the sigma is nothing but standard deviation. Mu is nothing but mean, sigma is nothing but standard deviation. mu is equal to n into p. N is nothing but the number of trials. P is nothing but the probability of success. Sigma is equal to square root of n into p into q. N into p into q, and that is the meaning of the sigma. Now let me give one example to all of you. Shall we do a lab? First theoretical lab we'll do, and then we'll do a practical lab. First, how do we do the manual? Manual is nothing but by using this formula: n factorial by n minus r factorial into r factorial p to the power of r into q to the power of n minus r. First we will do this formula. Then how do we apply the same thing in R language? Because as we are discussing R, then that is we will discuss. Okay. Let me write down the question. Please be careful. Please listen. We have a 12 multiple choice questions. Let's say 12 multiple choice question in quiz competition exam or in written exam. Assume that. So each question is having 5 possible answer. 12 multiple choice questions. Each question is having 5 possible answers. So each question has 5 possible. Out of 5 possible answers, only the one answer will be the correct answer. Each question is having 5 possible answers. Out of 5 answers, only one will be correct. Now this is the question they give. Now we would like to find out here what is the probability. What is the probability to choose 4 or less? What is the probability to choose 4 or less random 4 or less correct answers if we choose randomly? We have a 12 multiple choice question. Each question is having how many possible answers? 5 possible answers. Out of that, how many of them? Each 5 possible. Out of 5 possible answers, how many will be the correct answer? Only one will be the correct answer. What is the probability to choose 4 or less than 4 randomly correct answers? So out of 12 questions, what is the probability to choose the 4 correct answers? 4 or less than 4. That means 3 can be a correct answer. That means 2 can be a correct answer. 1 can be correct. That means 0 also be a possibility, right? Means I'm not talking about the answer. Randomly choose. Out of 12 questions I have attempted that all the questions. Randomly select all the answers for 12 questions. At least 4 answers. Out of 12 questions, 4 correct questions should be the correct. That means in that case, 4 questions can be correct in this case. 4 can be a correct answer. You can maybe select. There could be a possibility 3 may be a correct answer. There could be a possibility 2 may be a correct answer. There could be a possibility 1 may be a correct answer. There could be a possibility all the wrong answers. All the wrong answer. Is everyone clear with the question? Guys who are on the call?
Koti, this is example for binomial distribution, right?
Yes.
The binomial means it should have only 2, right? True or false, and 1 or 2, like that only.
Yes.
But here we have many options. 5 answers with one correct.
No.
We have 5 answers.
5 possible answers. Out of that, only one can be the correct answer. Yes or no answers will be there. Your answer is correct or wrong. That is the 5 possible answers. For each question, we have 5 possible answers. But we are not looking for the each and every answer. What we need to look at the end of the day, whether our question is correct or wrong. That is the ultimate goal for us.
Okay. True or false means the question is correct or wrong.
Yes.
We need to understand like. Okay.
Yes. Any questions about this? Everyone can able to see my screen, right? Hello?
Yeah, Koti, we are able to see your screen.
Yeah, thank you. And
Yes, Koti.
yeah, let me understand this question. Let me keep in the formula way. How do we write this one? For this, here what we will do, P is equal to probability of success. P is nothing but probability of success. As we mentioned in this case, out of 5 possible answers, what is the correct answer will be 1. 1 divided by 5. So what is the P value? 1 by 5, that is nothing but 0.2. Q means probability of failure. So that is basically 4 by 5. That is a 4 wrong answer. So that is nothing but 0.8. So R is 4 or less than that correct answers. That is nothing but less than or equal to 4. Less than or equal to 4. N is nothing but number of trials. Number of trials is nothing but 12. These are the number of trials is the nothing but 12. So in this case, how do we perform this operation? How do we perform the this one? Let's say the formula is NCR basically. Here n factorial by n minus r factorial into p to the power of r into q to the power of n minus r. This is for the binomial distribution. So basically n factorial means first is the 4 correct answers. So
Koti, you said n factorial by n minus r factorial into r factorial into p power r into.
No, p to the power of r into q to the power of n minus r.
Yeah, no. Here n factorial by n minus r factorial into r factorial, right?
No, p to the power of r, not the.
Sorry, the denominator, Koti.
Into r.
Denominator is right.
Okay, n minus r is nothing but, sorry, n is the 12 basically. 12 minus 4 factorial into 4 factorial. P is nothing but 0.2 to the power of 4 into 0.8 into 12 minus 4. Okay, this is the you have to calculate. No need to require to calculate manually. Just 3 correct answers will be there. 12 factorial divided by 12 minus 3 factorial into 3 factorial 0.2 to the power of 3 into 0.8 into 12 minus 3. Okay, next will be 2 correct answers. 12 factorial divided by 12 minus 2 factorial into 2 factorial into 0.2 into 0.8 into 12 minus 2. Like the same way, we have to do for the 1 as well as 0. Let me see how do we do. For the 0, how do we write for the 0? Let me write down the 0. Correct answer is, so 12 n factorial is 12 factorial divided by 12 minus 0 factor into 0 factorial into p is the 0.2 into 0 factor 0 into 0.8 into 12 minus 0 is the 12. 12 minus 0. 0 factorial is nothing but not 0, sir. 0 factorial is nothing but 1. 0 factorial is nothing but 1, not the 0. 0 factorial is nothing but 1. As for the mathematics, 0 factorial is nothing but 1. It is not at all a 0. So the answer for this, 12 factorial divided by 12 factorial into 0 to the power of 0 is the 1. 0.8 to the power of 12. That is the 0.8 whole to the power of 12. This is the answer for not all. When 0, correct answer. Like that, you need to add up the 0, you need to add up the 1, you need to add up the 2, you need to add up the 3, you need to add up the 4. Then only you will get the probability value. Here in this case, can anyone guess what could be the maximum value of our probability value? Yeah, the maximum value of our probability value would be 1, because ideally the probability value should not cross more than 1. It may be less than 1 in this case. Generally, ideal cases I am talking, probability value it can be a maximum up to 1. Ideally, in this case it cannot be an up to 1, but generally ideal cases it can be maximum 1. If your probability value is getting more than 1, that means there is some issue with your probability or your calculation. Is everyone is clear how do we do the manually? Hello, is everyone is clear? Any questions? If everyone is clear with this, how do we do the manual? Then we can go with the how do we do in R.
Discrete.
Yep. Thank you. And here how, so here we said the 4, 5 we can manage. What if 100 questions are there? What is the probability to choose 90 or less than or equal to correct answer? It will be really difficult to calculate manually, right? So what we need to do, we want to do these things by using the some tool. How do we perform these things by using, as of now we are discussing R tool. How do we perform these things by using the R tool? That part will do. D binom. D by is the distribution of binomial. D is nothing but distribution binomial. First the syntax will be N R P. Syntax will be N is nothing but total number of trials. R is nothing but how many successive trials you want to, how many successive trial you want to perform. P is nothing but probability of success. P is nothing but probability of success. Here, this example For example, okay, let me write down here. Okay, D binom, first our case, D binom, in our case, okay, you can, that is the general way, right? But in the syntax, how do we write? 4, that is a general syntax. But how do we write when we write in the R? Right? 0.2 comma size is equal to 12. This is how we will write in a R. 4 is nothing but number of trials when there are 4 correct answers. 0.2 is nothing but total number of, sorry, probability of success. Size is equal to 12 means number of trials. This is how we will write D binom 4 comma 0.2 comma size is equal to 12. 4 is nothing but when there are 4 correct answers, right? 0.2 is nothing but probability of success. Size is equal to 12. Size is equal to 12 is nothing but number of trials. Size is equal to 12 is nothing but number of trials. Right? Here in this case, here. So when there are only 4 correct answers, there could be a possibility when there are correct answers, 3 also, then we have to mention that again 2 also will be there. Like how do we write that syntax? First 4 correct answers is nothing but D binom 4 comma size, 0.2 size is equal to 12. 3 correct answers, D binom 3 comma 0.2 size is equal to 12. 2 correct answers will be there, that is equal to D binom 2 comma 0.2 size is equal to 12. 1 correct answer, D binom.
Could you one doubt here?
Yeah.
One doubt here.
Yes, tell me.
Size should come first, right? According to your formula, n comma r comma p. That means
Yeah, you can write any order. No, you can write any order, no problem at all.
Oh, okay.
You can write any order, no problem at all. 0.2 comma size is equal to 12. 0 correct answer means D binom 0 comma 0.2 size is equal to 2. Size is equal to 2. Here in this case, let's say here 4 correct answer. Let's say I have 100 question. What is the probability to choose 80 or less than 80 correct answers? So are you going to write it manually 80, 79, 78, 76, 70, 77, 76, 75 like that? It will be really difficult. So we are adding cumulative one. We are adding cumulative. So in this case, we are not going to use the D binom formula. We are going to use the P binom. P binom 4 size is equal to 12, P is equal to 0.2. Any order you can write, no problem. Okay. P is nothing but cumulative binom. P is nothing but cumulative binomial. P is nothing but cumulative binomial distribution. What it will does, here we mentioned the 4, right? 4 means it will take 4 correct answer as well as 3 correct answer, 2 correct answer, one correct answer as well as a 0 correct answer. Yes, it will take from that whatever the value which I have mentioned, it will take whatever the value which I mentioned here. In this case, mentioned 4 to whatever the values which are below up to 0. It will take all the values. Yes, P binom will take cumulative one, just adding up the, for example, here we have mentioned the 4. It will take the values from 4 to 0. For example, we have mentioned 90 to 0, 90, 89, 88, 87, 86, 85, 84, 83, 82, 81, 80, and so on and so on. 0, the last one, 0 will be the last one. For example, maximum operation, in this case, how many answers will be the correct in our case? Maximum to maximum. Maximum to maximum, how many correct answers will be there? 12, right? 12 questions are there. Maximum, how many questions will be the correct answer? 12 will be the correct answer. Is there any possibility 13 answers will be the correct? No, it is not at all possible. Right? For example, there is some twisted given like this. Assume that 12 multiple choice questions, right? There are the 4 possible, there is a 5 possible answer for each question. There is only one correct answer for each question. So what is the probability of success here? 0.2. What is the probability of failure here? 0.8. Now, if I randomly selecting, what is the probability to choose maximum 4 correct answer as well as at least 1 correct answer? Let me understand my question clearly. I request everyone, please write down 12 questions, 5 possible answers, only one will be correct answer. So here this is the n, here P is the 0.2, Q is 0.8, or we have say that like randomly selecting what is the probability to choose at least 1 correct answer. Randomly selecting what is the probability to choose at least 1, that means greater than or equal to 1 up to, yes. How many answers, how many questions? 1 can be a correct answer. There could be a possibility 2, there could be a possibility 3, there could be a possibility 4, there could be a possibility 5, there could be a possibility 6, there could be a possibility 7, there could be a possibility 8, there could be a possibility 9, there could be a possibility 10, there could be a possibility there could be a possibility 12 correct answers. Now if I take, how do I write manually? How do I write manually? First point, here in this case 1 minus total probability value should be 1. Here we need to consider when there is no correct answer, only we need to remove. We need to remove correct answer. When we need to remove from 1, we need to remove from 1 when there is no correct answer. So 1 minus 12 factorial divided by 12 factorial. 12 minus r means 0 into 0 means 0 factorial is nothing but 0 into p to the power of 0 factorial into 0.8 into n minus 12 minus 0. That is nothing but 12 factorial divided by 12 factorial into 0.2 into 0 factorial is the 1, 0.8 into 12. 0 factorial is nothing but 1. Sorry, to the power of 0, right? Not the 0. Total will be, this will be the 1. That is 1 into 1 into 0.8 whole to the power of 12. That is equal, simply we can say 1 minus 0.8 whole to the power of 12 will be our final answer. Right? Only we remove 0 only, right? Where? We remove 0. 1 minus, right? Total probability is the 1. So when adding up all the cases, it should be equal to 1. 1 minus, only we need to remove the 0 portion, right? Automatic remaining portion is my probability value. Suppose I want to write this in formula wise. How do I write? 1 minus d binom 0, 0.2 or size is equal to 12. Any order you can write 0.2. Next, if you want other way around, if you want to write, or we can write like this: 1 minus, how do we write? P binom 0 comma size is equal to 12 comma 0.2. 0 means it will take cumulative also, 0 only you can write. This is how, these many ways we can write the answer. Or you can write other way around also, or P binom 12 comma size is equal to 12 comma 0.2 minus d binom of 0 comma size is equal to 12 comma 0.2. P binom 12 comma size is equal to 12 comma 12 means P binom of 12 means 12, 11, 10 and so on. It will include the 0 also. So minus, we are removing the d binom of 0 comma size is equal to 12 comma 0.2. Okay. In 1 second. Oh my God. Any questions about this?
Yeah, Koti, actually here we didn't give Q value, right? So based on P value, will it automatically it will be take?
Yes, P plus Q will be equal to 1. That is nothing. Probability of success, probability of failure should be equal to 1.
Okay.
Based on the probability of success only, it will consider the Q value also.
Okay, thank you.
So I would
Koti?
suggest, yeah. Okay.
Sorry, carry.
Yeah, please go ahead.
Suppose this formula is for at least one correct answer.
Yeah.
So I want at least two correct answers. Then what will?
Then you need to write here P binom of at least two correct answers. So
Yes.
that means 2, 3, 4 like that, right? Two questions correct, 3 questions correct, 4 questions correct, 5 questions correct, 6 questions.
Sorry. Two correct answers I want.
Only
Now we are calculating one correct answer.
at least one correct answer. I'm not saying that only one correct answer. We are saying that in this question, at least one correct answer. So one correct.
I need at least two correct answers. That case, what is the problem?
So your question is here, if I not understand wrong, your question is at least 2 correct answers. That means
Yes.
2 can be a correct answer, 3 can be a correct answer, 4 can be a correct answer, 5 can be, and so on, like 12 correct answer. Like that is right.
1 second. No, actually, there is 5 possible chances is there in this question. So now we are calculating 4 or less correct answers. Means 1 by 5, 4 by 5.
Yes, I agree.
But I want 2 by 5 and 3 by 5. Like 3
Then,
possible success.
yeah, then if that would be the case as per you, the P is equal probability of success, 2 correct answers will be 2 by 5. Q is nothing but 3 by 5. Here in this case, the probability value is going to change 0.4 and Q will be 0.6. Simple. So as per your case, so what the question is, we have 5 possible answers, right, for each question.
Yeah.
In this case, A, B, C, D, E. So there is a, I mean, actually, as we discussed, the question is 5 possible outcomes basically 5 possible outcomes. Out of that, only the 1 correct answer, right? Multiple choice question, 12, I mean, multiple choice question, 12 questions. Each question of 5 possible outcomes, A, B, C, D, E. As we saw so far, what we see, only 1 correct answer. Out of 5, only the 1 correct. But now he is asking 2 questions are correct. 2 answers are correct. That means 2 by 5 is the answer. P, probability of success. Q is equal to 3 by 5. When we mention the formula D by now, 4 comma 2 by 5 is nothing but 0.4. Size is equal to 12. Is it clear?
Yeah.
Or is it not clear? It seems you are not clear still.
Actually, my question is different.
What is
actually we are using n value equal to 0 in for last time. 1 minus denom of 0 comma 12 comma 0.2. So I want denom 1 comma 12 comma 0.2. Is it possible? 1 minus.
Let me write. Tell me correctly what you want, right?
1 minus.
1 minus.
P binom.
P binom.
1 comma.
1 comma.
Size 12 comma 0.2.
This give us 2.
I want.
Yeah, it will give us answer at least 2 correct answers. 2 more than 2 correct answers.
Yes, I want at least 2 or more than answers.
That is what I told you, right? If you said none, not. I asked in the middle also, I said, right? 2, 3, 4 correct answers will be there. Okay, that's fine. Finally understand. Yes, we can write this. Okay. In this case, it will give us at least 2 correct answers. Okay. Now, where do we use this binomial distribution? Okay. Where do we use binomial in logistic regression? We are going to use the distribution, binomial distribution. Basically, in logistic regression, logistic is the one of the thing, like in this case, the dependent variables and independent variables, as we discussed, dependent and independent events, right? In the logistic regression, the dependent events, only the 2 cases, those are 0 or 1. To find the predicting probabilities, in that case, we are going to use the binomial distribution. When we discuss about the logistic regression in detail, there we'll discuss again about the binomial distributions. Okay. When we're discussing about the logistic regression in the future, at the moment we will discuss again about the binomial distribution. But as for your remember point, where do we use this to understand about the binomial distribution? I mean, where do we use as an algorithm binomial distribution? In logistic regression, we are going to use it, but it will be very early to explain about the logistic regression. So drawbacks of binomial distribution. Here drawbacks. First point we said, in the points we said, number of trials are fixed, right? Number of trials are the fixed, as I mentioned, the first assumption or first property. Does number of trials performed in the same place, let's say I said number of trials are 1000, that means n is equal to 1000, am I right? Does 1000 trials are performed in the same day, or does the 1000 trials are performed in the same week, or different week, or in the same year, or in a different year, or in the same zone, or in the different region, or different globe? Maybe one will perform at the America, one will perform India region, maybe one will perform Earth, one will perform maybe on Moon. We don't know, right? So binomial distribution is not the time constraint one. In binomial distribution, time interval is not included. To measure the time interval, or space or region, we are going to use Poisson distribution. We are going to use Poisson distribution. Sorry. In binomial distribution, time interval is not included. To measure the time interval, we are going to use Poisson distribution. Okay. To measure the time interval or region or space, we are going to use the Poisson distribution.